Hey everybody, thank you for attending yet another LIDNUG event. Today we're going to show excellent REST using ASP.NET with Maurice DeBeja. This is an event that's planned in association with DevelopMentor. Before we head into some of the information about LIDNUG, I'm just going to quickly thank our sponsors. AUXWeb, Telerik, Inner Workings, Pluralsight, Winternet Now, and Syncfusion. As usual, your support is so very much appreciated, and without all of their help and assistance, we simply just couldn't do what we're doing. Little info. If you have a question, comment, or just want to get in touch with us, send an email to info@lidnug.org. You can also catch us on the social at twitter.com/lidnug, facebook.com/lidnug, and all of our recordings are uploaded to our YouTube channel, and that's youtube.com/lidnug. Our website, which is undergoing a very long-winded refresh, you can find at bit.ly/lidnug. A bit about upcoming events. It's not for August. It looks like my slide deck is a bit broken. October and November, we have Maurice coming back twice. The first one on October the 16th, doing practical HTML5. And on November 14th, he's going to be doing getting started with Angular.js as well. For more event listings, you can go to linuxevents.eventbrite.com. A little bit about Maurice. He's an independent software consultant. This is his first LIDNUG event, but we have 4 or 5 planned in this year already with him. He's a teacher at DevelopMentor and pretty much does the entire web stack. He also has a blog, msmvps.com/blog/the-problem-solver. He also has a podcast for the Dutch .NET user group that he helped run, and of course he's a presenter. Last but not least, the spread of attendees and registrations this time around. Quite a few from the US, a couple from South America, a bit of a spread around Europe, India as well, and one from Australia over east. That being said, I'm in Australia as well, but I'm sitting on the west and it hasn't picked that up. Anyways, I'm going to hand over to Maurice.
Okay, thank you. Welcome everyone. Let me start with sharing my screen. So everyone should be able to share my screen in a moment. So everyone should be able to see my slide deck now. So let's hope that's working fine for everyone. Like I said, welcome. Good evening, good morning or afternoon, wherever you might be. For me it's evening, just past 7 p.m., based in the Netherlands. And in this session we're going to talk about excellent REST using the ASP.NET Web API. So, introduction was pretty much done already. There's just one thing I'd like to add. I'm not a full-time instructor for DevelopMentor. I do this work most of the time for real, so I combine instructor teaching with real life world experience, which I always think is a win-win, because you have to think about stuff and you gain real world experience. Other than that, it's been covered, so we can skip over that. So what are we going to cover this evening? We're going to take a look at what REST is, what does REST stand for, how did it come around. Then we're going to take a look at what the ASP.NET Web API is, how was it created, what is its purpose, and we're going to take a look at hypermedia and how hypermedia can take your REST services to the next level and how ASP.NET Web API can help you do so. But first, what's REST? If you look it up in Wikipedia, REST basically is described as representational state transfer, which doesn't really tell a lot yet, but it's an architectural style that abstracts elements within basically a distributed hypermedia system. So the important part is it's an architectural style. It's not a specification like SOAP or HTTP or HTML. It's just a style of how to create application. And it's meant for distributed systems. With a REST service, there is always a clear indication of, okay, this is the server, this is the client. There are very particular roles. I will mostly be talking about the server part of it, but the client plays an active role in this. So where does it come from? Well, there was this guy called Roy Thomas Fielding, and he did a doctoral thesis back in 2000, so quite some time ago. And in that he describes REST-style applications. So some student writing a thesis, well, everyone picks up on that. How come? Well, it turns out Roy Thomas Fielding isn't just anyone. He is one of the 3 authors of the original HTTP 1.0 spec. Of course, Sir Tim Berners-Lee, everyone knows about. Well, he had 2 assistants, and Roy Thomas Fielding is one of them. So he really knows HTTP, why it was created the way it is, how it works. And he basically took the HTTP standard and everything it intended to do and created that, or used that as a basis to create an architecture for distributed applications. So that's the origin. So that kind of leaves us, okay, well, that's nice, but what's HTTP then? Well, if you look up the definition of HTTP, it's not just a communication protocol, because most of the time we tend to think of HTTP as a communication protocol for sending requests over the web and retrieving some data, web pages, stuff like that, or posting some data back. But it's actually much more than that. Originally, it's an application level protocol for distributed applications. And the other important part, it's a generic stateless protocol. So it's not just for serving up web pages and doing the occasional form you fill in and post back to a server. It's much more than that. And the World Wide Web, as we know it, is just one huge application which is built on top of the HTTP standards. Well, as we all know, the World Wide Web's become pretty big, pretty popular, scales pretty well. Of course, it breaks down once in a while slightly, but for the most part it just works and it just keeps on scaling. And we've been predicting it to, well, stop scaling, fail for years, but so far it hasn't happened. So far it's stood up to that. So I guess that kind of proves that HTTP is a pretty reliable protocol to work with, a pretty reliable standard for basing applications on. So if it's good enough for the web and everything built there, it's certainly more than good enough for our own applications. So when you start looking at REST service, there's this guy called Richardson who basically came up with a model of where you are with a given REST service. So right at the bottom, level 0, what he calls the swamp of POCs, plain old XML. We're basically at the level where we just send some XML across the wire and don't really think much about it. The next level up, which is pretty easy to get to, you start thinking about resources. Resources are data items, things like maybe books, authors, contacts. Not necessarily something you store in a database, but typically you can think of that as being stored in a database. Most of the time it will be so. Not always. Your resources might be the current state of hardware you're monitoring, say you're in a fabrication plant or something. Could be anything like that, but for most business applications, if you think of database records or combination of records, you're pretty close to what it is. So not very hard. So the next level up is starting to really leverage the HTTP spec. It says verbs here, but there's quite a bit about the HTTP specs like status codes, content negotiation, which you get to at this level. Still not incredibly hard to reach. This is actually the level where most people end up. But if you look at Roy Thomas Fielding and how he defines REST, it's actually a bit more complex than that. And if you want to do REST the way he described it, you need to go all the way to level 3 and create hypermedia controls and a complete self-describing document with internal links describing what you can do, how you can interact with data, how you can get more data, etc. Now, most REST services out there don't actually contain any hypermedia. Most just stay at level 2, use HTTP verbs, use resources, etc. If you ask Roy Thomas Fielding, is that a REST service? He's probably going to say no. Does that matter? Probably not. I'm always pragmatic about those things. I'm more concerned about its usability. And if you control the client and the server and you know what's going to happen, being at level 2 is perfectly fine. If you need a public-facing REST service where you want to be able to version things, change how things work, have different capabilities for different clients, like a guest user might be able to read data, but an administrator or a preferred customer might be able to change something. An administrator will probably be allowed to change anything. And you want every resource to be self-describing there, so the clients can basically adapt, the client application can basically adapt to whatever it receives. Well, then you need to go to the full hypermedia level. But getting from level 2 to level 3 is quite hard. Think of hypermedia as basically a domain-specific language where you start adding your domain knowledge into your REST formats, and doing so properly is quite hard. Which is probably the reason that most people stay at level 2, because most cases you don't really need to. Personally, most of the REST services I've created just stay at level 2, and there is no need to go to level 3. So even though, technically speaking, some people will say that's not a REST services, they might be right, but it's good enough, so no need to do the additional work. So what's ASP.NET Web API? Well, REST is just a style of an architecture. There is no actual bits there, nothing to code against. So the ASP.NET Web API is a framework for .NET applications to create RESTful services and to a smaller degree also consume RESTful services. It's mostly concerned with the server part, and for a small degree it's also concerned with the client part. Using ASP.NET Web API, it's actually pretty easy to build REST services where you get to level 2, where you use the HTTP verbs, the status codes, the methods, the content negotiation, and all those kind of things. You can use it to get to level 3, but so the full hypermedia is perfectly capable of doing that, but it does take quite a bit of work. And in the next version, they'll be adding more things to ASP.NET Web API to make it easier and even more capable. But even today, with the currently released bits, that's perfectly possible, and I'll have some short demos of that at the end of the presentation. So before I go to the other slides, let's actually go to Visual Studio for a moment. If you want to create a new REST service, create a new project, select ASP.NET MVC4 application, click OK, and you get another little wizard. You get this wizard, which basically gives you a list of a number of templates you can use. And right here in the middle, I forgot to activate one thing, so bear with me for one moment. Let's fire up Zoom it. Yeah, that's better. Now I can zoom in. Over here you see this thing, Web API. That's by far the easiest way to get started, but it's also kind of misleading. This kind of suggests that Web API is part of ASP.NET. It is in a functional way, but technically speaking it isn't. Web API has been developed separately from Web Forms, ASP.NET, MVC and all those kind of things, and doesn't have a dependency on it. In fact, Web API doesn't even have a dependency on system.web. You can host a Web API REST service without using anything from system.web. So it's part of this template, but it's the easiest way to get started with it, but it's by no means necessary. You can create a console application and set the proper references and host this yourself. In fact, this is one of the applications, or one of the project templates, one of the frameworks I should say, where they're using Katana, which is an OWIN-based host as the hosting infrastructure, and Katana is just a way of hosting it. In here it's hosted inside of a web application, but the end result is the same. Now, I'm not going to press OK here because I've already got an application open, which was actually closed by this, but let's reopen it. So if you run through the dialog and click OK, you get this kind of folder structure. Now, everyone who has done any ASP.NET MVC work will recognize most of them. I've added a few, so formatters wasn't there by default, API wasn't there by default, but things like controllers, images, models, scripts, views, all of that's there by default. And it turns out that by default this is actually also an ASP.NET MVC application. Like, there is a home controller, which, if it opens up, is just a regular controller. We're going to ignore that for now. By default, inside this controller folder, you'll also find a simple API controller. Now, I prefer not to put my API controllers inside the controller folder because they've got a very different purpose than my MVC controllers. So I keep them different. What I typically do is I create this API folder and put all my API, my REST controllers in there. So why API? Well, another thing used is routing. And when the application starts, it uses the web API config.cs for routing, and it creates a route here, which starts with API/controller/ID. So it looks pretty similar to what happens with ASP.NET MVC, where you've got a route which is controller/action/ID. But in this case, they all start with API because that's the way the default route is set up. And for that reason, I just create a folder API, so it kind of matches the default route used. You don't have to do so. Basically, create your controllers wherever you want and they will be found. But it's a nice, convenient thing. So what does a simple controller look like? I'll create a new one for a moment, but basically the most important thing to remember is you've got to derive from something called API controller. So with MVC you derive from controller, with web API you derive from API controller. And once you do that, then the framework is able to pick them up, routing will work, and things will get routed through them. So creating a new one is real simple. There are a couple of different ways you can go about it. Add, we can choose controller, and we'll get the dialog everyone knows from ASP.NET MVC, at least I presume everyone who has worked with it knows. And you see the top three options here are about MVC controllers. The bottom three are about web API controllers. So I can create an empty API controller, or one which actually hooks up to Entity Framework, or another one with empty read-write actions. So I could just do this and call this say demo controller. This name is important. The name has to end with the word controller, just like it is the case with ASP.NET MVC. But right now I would create something which I could reach using the URL API/demo and then slash something after that. So if I click add, all I get is this little simple empty class. Nothing much to it. Of course, I could have just created a new class. Just make sure to call it controller, derived from API controller, and I would have been good to go. So before I add something to this, I'm actually going to do a quick demo of what you could end up with. I've got a default HTML page here, and I've got a bunch of styles. Let's ignore that for a moment. I've got a tiny bit of markup. Basically, the most important bit is this unordered list element. It basically contains nothing now, but it will be populated by data being returned from a REST service. Below this, I've got some jQuery codes. Basically, over here, when the application loads or this page loads, I'm going to do a JSON request to a specific URL. And when that finishes, it receives something which is called books, so presumably a collection of books. And I'm going to iterate over them, create a list item, and append that to that unordered list. So basically, this empty HTML or almost empty HTML page dynamically loads this data and then dynamically adds items to that list as per returns. I've also got some additional functionality. If I click on something, I'll get a little edit window, and more interestingly, when that edit window is submitted, I basically create a little object with the data and then use the jQuery AJAX function to post it back, or in this case actually use the HTTP put method to send it back to the server as JSON. So this would be a pretty simple but functional kind of client you would write. Now if I run this, assuming it runs, there it is. So it's loading data. Now we can see that from the little spinner that appeared at the right top of the screen. Let me resize this a bit and refresh, and maybe that's visible again. No, I'm afraid the second time it's too fast, so the spinner doesn't even show up. But like I said, I can click on something, get a little edit window, and say, suppose R.C. Clarke should be a little more up to date. I can change the title and hit Save Changes. Now, if I open up my network window here and refresh, we see that initially we get some HTML and jQuery, and we get this API call. And when I click on something, you see we get another API call. When I save changes, yet another. All of those are the actual data being returned. So the first API call books, you see, returns a collection of, well, in this case, JSON formatted data. If I click on an individual, you see a single book is sent. Let's see, where did I save one? So this was a request where I actually saved it. I didn't make any changes, but you can see over here the data being sent and the HTTP headers, etc. Pretty simple client, but that's the kind of client you might write. Now I've done a pretty simple thing here with jQuery. To be honest, most of the time I wouldn't actually do it like this nowadays. I would use something like Angular and have a much richer client, but that would be kind of making this demo too complex because Angular is quite a big subject. So I did the minimal work with jQuery, which is still pretty functional. Later this year I'll be doing another talk for the LinkedIn.net users group where I'll show you how to create an Angular client application, and I'll use web API service like I'll be creating today to work with. So that's why this relatively simple client demo. So let's go back to the server. We'll take a look at the server, the web API controller, which I used for that demo in a moment, but let's first take a brief look at creating a new one. Let's actually run this again, and let's try the URL we just used for books. Basically, I'm doing a request, and on the route API/books, I'm going to a controller called books controller, and it returns this. So what does this request do? Let's do it again with network open. Basically, it says it uses a request method get. And with the web API, the convention is to create public methods with whatever HTTP method name you want to support. So this controller doesn't do anything yet. So let's actually go and check. So the requested resource does not support the HTTP get method. So in order to add it, all we need to do is create a public method here called get. So let's just return a string for now. String does need to be between quotes. This is some data. And let's recompile and refresh this, and now it should actually go there. And you see the data back. This is some data. It's returned as XML now, as a string. We can get things in a different way, we can get more complex things, but that's as simple as it gets. So suppose we want to do something like we did with our little jQuery client, return a list of books. Well, in my models folder, I've got this little book repository, which is just a simple, very simple in-memory repository, but I can use that. So basically add this in here. Add a new books repository, and instead of saying this returns a string, I numerable of book, so basically a books collection. Repo.getBooks, which basically just returns all of the books in the collection. Let's rebuild, refresh this, and we should see the list of books returning. And there they are. Now, sort of a convention in REST is that if you hit a URL like this, where basically this stands for some reason, so this, I guess this should have been called books, and we do something like this, tag on something, we're asking for something inside this. So the original URL like this with demo is a collection, slash something is a specific item in that collection. Now that one in this case would stand for an ID. It would be perfectly legal to type in a title name or whatever you think is appropriate to identify an individual book. So I could do the book title here, I could do an ISBN number, do whatever you think is appropriate. The basic rule though is this one doesn't indicate that it's the first book. It means it's the book with ID 1. So it's always going to return that same resource. It's not like it returns the first book, and if I delete the first book, then demo/1 will just return the next book in the list. It's always going to return book 1. If you delete it, it's going to return an error that there is no book with ID 1. So if we want to implement that, we will basically have to do another get, because we're still doing a get, but the difference is this actually gets something by an ID. So we get a single book back. Get int ID. And my repository has a getBook method where I can pass in the ID and it will just return that specific book. So let's recompile this, and now we can actually go here. So you see this returns the Ultimate Hitchhiker's Guide from Douglas Adams, and book 2 returns Space Odyssey from Arthur C. Clarke. So that's actually pretty simple. I basically get something of an integer type in, and I return whatever I type I want to do, and Web API just makes sure that this book is actually sent out in the right serialized format. In this case XML, but that wouldn't necessarily be the case. That's something I'll come back to later. I can create this with a different parameter, but it does need to be called ID right now. Suppose I call this book ID. Do the same here. Recompile. This is going to fail. Let's try again. It just returns the complete list. It never actually goes in here to find a specific book. It just says, well, you're doing a get. We can't match this to this specific book ID, so it will just return the complete list. How come? Well, that's where routing comes in, which is in the Web API config. This runs at startup time. And basically, in here, let me zoom in a bit, it says create one default route, and it's actually using the name ID there. So this name ID matches with our parameter name ID. And because I changed that parameter name to something else, it no longer matches, and it falls back to the default get without any parameters. That doesn't mean that I can't create a get function with a parameter named book ID. It just means that I've got to create a specific route then for that and put book ID in here instead of just ID. I typically leave them as ID. I kind of like just using ID, so let's just revert that and make this ID and have things work. So now we'll get a single book back again. So that's where this routing is very important. Just like with ASP.NET MVC, where routing determines what request goes where. Well, with Web API, it's the same routing that determines what request goes where and which parameters map to which input parts. So this name matches, and because of this default ID being optional, it isn't actually required. If I left that out, it would actually be required. Now you can create as many routes as you like. Just make sure that they're ordered in the most specific to the most generic, because the Web API basically starts looking at incoming requests and takes the first route which matches. Now you can put restrictions on here, so you could put a restriction on here that the ID should be only numbers, and you can create another route where it could be something with an ISBN number and yet another with a string, etc. Just make sure to order them in such a way that you don't put a string one first, because an ISBN number and just any integer number will also be a valid string, so that would always resolve. Put the one with just a number first, because that's the most specific, then the specific pattern for an ISBN number, and only the generic string, which could be, for instance, that book title, as the last option. So make sure your ordering is correct. Let's actually go back to the slides for a moment. Because right now I've created an API controller which was really simple. I just returned a book, a .NET type from my get method, and things would work. But there are cases when you need a bit more control. There are cases where you need to worry about something being returned. Like, if I go back for a moment to my browser, if I ask for book 2, that's an existing book. But if I ask for a book with an ID 22, there's no such thing. But now I'm just returning a null, because that's the way my repository was set up. And instead of getting a message that the book I request doesn't exist, I'm actually getting a null reference inside my XML, which is probably not what I want. In this case, if you look at the HTTP specs, there is a status code for 404 not found. And in this case, I'm looking for something which doesn't exist, so I really would expect that HTTP status code back. Well, for those kind of things, you want to be a bit more in control, and you might want to use HTTP response messages instead of your rich types. If I do this same with my books collection, so books returns the list, books/2 returns a specific book, but if I do books/22, which doesn't exist, now my browser window is blank, but if I scroll to the bottom, you can see I get an error. I get the status code 404 not found, which I just mentioned a minute ago is what I expected. So how do we do that? Well, let's go to my actual book controller and see how it works. You see that the regular get is just as simple, just return all the books. But you see that the get for a specific book is actually a little different. Instead of returning a book, I'm returning an HTTP response message. And the HTTP response message lets me return whatever I want. I get complete control over the HTTP response message being sent. In this case, I want to differentiate between finding a valid book and not doing so. So basically, I'm asking the repository for the specific book. If I get the null reference back, then I basically say, well, create me a response message with an HTTP status code 404 not found, and return that. If we've got a book reference, then just go in, create another response with an HTTP 200 status code. Okay, so everything went correct. Include that specific book as the response body and send that. Now in this case, I'm not doing a lot with the response. All I'm doing is determining the HTTP status code, but this response message will let me tweak the complete response. I could set additional HTTP headers, I could set caching controls, I can do anything I like with specific requests formats being sent back. So I get complete control over how the message is actually formatted. And this is the common way of doing things. So a couple of the other examples I mentioned, setting caching headers. Caching is one of the things that makes the web scalable. If you request the same resource often and you know it's not a resource which is likely to change anytime soon, well, why bother retrieving it from the server all the time? The server has better things to do. In that case, just setting caching means that a client might get the data from its own cache, it might get it from some intermediate cache, or if it's not in any cache, it will still get it from the server. Now, most data is actually cacheable. It turns out there is very little data which is not cacheable at all. Some data is very static. If you think like the list of countries in the world, that doesn't change very often, and certainly not all of a sudden. So that's a kind of thing you could cache for weeks, months, maybe even longer than that. If you think about a sales application where you're selling material, you might say, well, my articles, they tend to change, the prices on them tend to change, but not that frequently. It's not like they're going to change every second. So setting caching to maybe an hour or maybe a day, or if you frequently change them, maybe 15 minutes or so, will help a lot. The first client will actually do the request and it will go to the server will satisfy it, but subsequent requests from that client will be served up from the local cache and not consume any server resources and any networking bandwidth. Now, caching is not something which is just client and server, it's also very much intermediaries, like you can have caches at ISP level, you can have reverse proxy caches before a server to serve data. So they're very useful and it's highly recommended that you use them to create much more scalable services. Another thing where you could use HTTP headers is, for instance, concurrency checks. There's an HTTP header called an E tag, and you put something in there, some kind of value you decide, which actually determines the version. And when you can do a GET request using an E tag, basically saying, okay, only give me your resource back if it has been changed. Now, a request like that has to go to the server because typically only the server knows if it's changed. But if it's a big resource, he might actually respond by saying, okay, it's not changed, the one you've got is perfectly valid. Another place that's used is when changing data. You basically get a resource, you've got the local copy with an E tag, and in that case think of the E tag as a version number. You send it back to the server containing that same E tag, and then the server will only update that resource if the E tag is still valid, if it hasn't been changed by someone else. And if it has been, you'll get an error status back saying that there is a concurrency error, stuff like that. So just a couple of the examples where you would use HTTP headers, but some of the more common ones. So here's the basic web API controller, which I just demoed. This is kind of like the one you get out of the box, which returns 9 numerable strings. Probably not the most useful, but still a good place to start. We've already seen the web API routes, where you basically define how incoming URLs map to API controllers. Anything you want, which you can do in a route goes, just like with ASP.NET MVC. So if you want to map them to different methods, you want to do some kind of RPC style, remote procedure call style invocation, you can define routes for that. Create as many as you want, but like I said before, make sure to order them in the most specific to the least specific, because they're evaluated in the order they're defined. Here's the default map HTTP route, which we just saw. So another thing is content negotiation. I just did the GET from a resource and I got back some books. So books were the actual resource I got back, but I got them back as XML. And XML is just a serialization format. Actually, when I run my jQuery client against it, it actually returned them as JSON data, because JSON is much easier to work with inside of a browser. JSON is the natural language for JavaScript to work with data, so natural choice. So this is actually the result of a process called content negotiation. And it's actually quite easy to get to see this to work. One program I use a lot for REST style work is Fiddler. Fiddler basically lets you monitor and create requests or HTTP requests, so also REST style requests. So let's go back here for a moment, do this request again. We get a single book. But if I switch back to Fiddler, we see Fiddler picked up on this request. If I go to this raw view, you can actually see the response here. This is the response message that it's sent an HTTP version 1.1 200. The content type is application/XML, and the data here is looks like XML. So why is this application/XML? Well, basically because we asked for it. How did we do so? Because we never actually specified that anywhere. But the browser, as part of the request being sent, actually added this header, the accept header. And this accept header basically says, okay, I want text/HTML or application/XHTML or application/XML or something else. And because over here it says application/XML, our service actually says from, okay, you prefer HTML or XHTML. There's no qualifier there. This Q equals 0.9 is the qualifier. And if it's missing, that means a qualifier of 1, which is the highest possible value. It couldn't satisfy any of those types, so it basically went down and said, well, there is another request type, application/XML, which I do understand. And it has a qualifier of 0.9, so that's pretty good. So let's do that. So that's why we actually got this back. Now, one thing Fiddler lets us do is create messages. I can basically drag in a message in here into the composer and start tweaking it. I can execute it. And right now I've basically just repeated my original request. But I can tweak it, as I said. I can go in here and say application/JSON. So I don't want this as XML, I want it as JSON data. And if I resize my windows a bit, we see we've done the same request. Same URL, but the body sizes here are pretty different. And the content type is not completely visible yet. Now it is. See, the content type for the first was application/XML and the second is application/JSON. So by just changing a simple HTTP header, I got back a different result. Still got the same book, but now it's served as, where is my content type there? It's served as JSON and the data is actually still there. The resource is the same. It's the same resource, no change, but it's served up as JSON data instead of XML. Now this is a standard HTTP protocol thing. The standard HTTP protocol describes content negotiation where you can have either client-driven or server-driven, but in this case the client sends an accept header. So it's basically saying in this case we're accept application/JSON. The server responds to that and says, well, okay, you want it in application/JSON, I can support that, I'll give you your resource in that format. In the web API, if you do something else, suppose I do say image/JPEG, give me this book resource as a JPEG, it will actually return it in what it finds is default. This is something specific to web API. The standard actually suggests that you return a not supported, but servers are free to do it different, and the web API actually decided, well, we're going to return application/JSON no matter what if we can't specify the content type you actually requested in the accept header. So as a client, you should always check the content type, not say, well, I only added one single accept type, image/JPEG, so it must be an image/JPEG. I got back, no, it doesn't have to be. It could be something different, so make sure to check. But if you think about resources, well, a book resource, well, application/JSON would probably contain the data in a JSON format. Application/XML would probably contain that same data as XML. But getting that book back as an image doesn't sound very strange. It could be the cover, and I could ask for that book as a PDF and basically get a PDF with the complete contents of that book. So it's still the same resource, it's just a different way of describing the resource. something which is very common in RESTful services. Basically remember that a resource is what we send, the book, or a list of books, or a contact person, or whatever. And the format is just a serialization format. JSON, XML, where you actually send data, or an image, or something else altogether. I suppose we wanted to enhance what our service could. We can actually start explaining it how it should serialize a book as an image. It turns out that the web API has something called a media type formatter, and a media type formatter is basically responsible for taking some resource and formatting that as a specific media type. Out of the box, there are a couple. There is one for JSON, which is actually the default. If all else fails, it will fall back to JSON. There is one for XML, and both of these are for in and outgoing messages. And there is also one for URL encoded data, which is only used for incoming messages. So you could basically post a form, submit to a RESTful service, and it would understand it, but you couldn't actually retrieve it. Now, creating your own media type formatter is real simple. Basically derived from the class media type formatter, or in this case buffered media type formatter, which is a little easier to work with. The web API is actually through and through async, so internally it returns tasks all over the place, and the media type formatter does exactly the same. The base class, it returns tasks of media type formatting. So the buffered media type formatter just gives you a stream to write to and a stream to read to. So I've actually got one in my project. In this formatters folder, I've got the JPEG media type formatter. And basically this understands how it should convert a book image, or a book resource I should say, to an image. So basically I've created my JPEG media type formatter saying, okay, I support the following media types, in this case just image as JPEG, but you could do multiple ones, including those qualifiers saying, I prefer this, but I can also do something else. There are two overrides can read from an incoming message. In this case, we're not deserializing incoming JPEGs. Can write type? Can we serialize this type as an outgoing JPEG? Well, if it's a book, we can. How come we can? Because the book has an image name property, and those images are on disk, and basically it just grabs that image and writes it up. So why did this do? I just requested my book as an image/JPEG. Well, we do need to do one more step. Go to the config and actually configure this. So the config object has a formatter connection, and I'm basically just adding a new JPEG media type formatter, specifying the path to look for in here in my images. I've got things like a spatial odyssey, etc. So if I recompile this again, go back to Fiddler and repeat this same request, you see we get something which is a lot larger, and if I open up, we actually see that we get a book, an image representation of the book. And if I ask for a different one, say book 1, we get the Hitchhiker's Guide to the Galaxy. Now the way this formatter is set up, it only supports outgoing formats, but if I also want to support incoming formats, basically return something else here. And there is a read from stream override where you basically start reading from the input stream and you deserialize things as you need to. But pretty easy to do. So very nice, very flexible. easy to work with. Of course, you can create as many as you like and do all sorts of interesting stuff there to enable very rich client behavior. So another thing to look at are the HTTP methods. So far we've only done a GET. Actually, during my small demo with my jQuery client, I did do a put to change things. But other than that, I've only done GETs, the most frequent used HTTP method on the verb, because we do GETs with web pages all the time. And if you look at HTML, it's basically GET, or when you start doing forms and posting those back to the data, we actually use the HTTP method POST. But it turns out that, well, with HTML you only use two, that HTTP supports many more. In fact, the list is open-ended, it's not a finite list, so you can create your own HTTP methods as you want to. And doing that, we can map to database CRUD style actions pretty well. So the create, read, update, delete style actions we do with database, with SQL commands, etc. Oops, I see I've left something in Dutch here, sorry about that. The first column should be action. So that's the CRUD style action, create some resource, so a SQL insert. Well, with HTTP that's normally done with a post to the collection. So I post something to the URI API/books. Read an HTTP GET, which we already did, either to the collection or to a specific one. If we want to update things, we normally do an HTTP put. We basically send up a complete resource and it completely replaces the existing resource on the server. Now sometimes you don't want to do complete replaces, you just want to do partial replaces. In that case, the patch is the sort of semi-standardized HTTP method to use, although you'll sometimes see merge being used. In that case, it's expected that the server will merge whatever you send to it with its existing data and create one new resource out of that. And of course, the delete HTTP method matches very well to the delete CRUD action or SQL statement. So creating them is real easy, just like when we did that. All we had to do was create a method called get. With post, we create a method called post. With put, we create one called put. With patch, we would create one called patch, etc. Delete, create one called delete. Now, in fact, you don't have to use this naming convention. Sorry about that. Suppose you want to use a method called getBooks. That's perfectly fine. The web API will basically say, okay, it starts with get, so it respects or responds to a get HTTP method. It starts with post, so it could be post book, post my new fancy book, or something like that. As long as it starts with post, it will still respect a post HTTP method. Now, if you want to name your method something different, so you want to have a public void insert instead of post, but still react to the post HTTP method, you could add attributes to your method and basically say, okay, response to the HTTP post method, response to the HTTP put method, etc. But just using the naming convention is by far the most common, because your controller kind of tells you what kind of resources it is. In this case, it's demos. So we're getting a collection of demos, getting a specific demo, posting a new demo, putting an existing demo to a new version, or deleting an existing demo. So I tend to stick with those names, although you don't have to. Before I get to hypermedia, let's actually take a look at the controller I implemented, the books controller. You see here how a typical post works. This is the post method. So it expects a new book. The reason it actually understands the fact that there is a book incoming is because of model binding, just like with ASP.NET MVC and nowadays with ASP.NET Web Forms as well. We've got model binding, which actually looks at the resource and the method signature and tries to convert the incoming message to that correct type. So basically the serialize it, set properties, etc., which works perfectly well in most cases. So that's created a new book for me, and I just call my repository to add a new book. And if everything went well, I'll create a response message. And the convention with creating new methods is not to return a HTTP status 200 OK, but to create a 201 status created. And additionally specify a location HTTP header where you can retrieve the new resource. So that's what I'm doing on this line. Basically result.headers.location, and I'm using the URL.link helper to create the actual URI needed. And if that went fine, I'll just return it. If not, some exception occurred, a validation exception, because the data, for instance, wasn't valid. Maybe I left the title empty, and a book without a title really isn't much use. In that case, I'll just return a not acceptable message. So an error HTTP status code and specify the actual exception message, or it's really up to you what you want to put inside of that message body. Just make it something which is usable by a client. Just returning not acceptable is not that useful. I post something to the server, it says not acceptable, but I've got no clue why, so I can't fix the problem. So add something there which actually helps. Put specific. Just like with post, we use model binding to accept the new book, the updated version of an existing book, I should say. Basically, I'm also checking the ID from is the book posted using a URL which actually matches it. So over here I check if that matches. If not, throw an invalid exception. You're posting book 1 to the URL of book 2, for instance, not valid. And if everything went well, I just update the book and return a status code 200 OK with the actual book resource. Now whether you include the resource here and the same with the post, that's up to you. It's perfectly fine to say everything went well, I'll just return an OK status, because with the put, I'm updating the resource with the resource I specified, so I should know what's inside it. And with the post, that's for the most part true, except the ID is probably server generated. So I would want to know the ID, but I do get the location header back, which will tell me where I can find the resource so I can get whatever I want from it. I typically just return it because put and post are not that common. Reading is far more common than writing. So adding a bit of overhead by adding some content to the message is usually not a big issue. Of course, if you want to maximize your throughput, be as lean as possible, just leave this out because it's usually not really needed. And the deletes, no big surprises there, I would assume. We've got a delete action taking the integer of the book to delete. I just return, I delete the book and then return OK status. In this case, actually no content because I didn't add anything. The reason I don't add the old book as a content here is that REST services should be idempotent wherever possible, which means that an HTTP request should be repeatable, and if you repeat it, it should produce the same result. Well, if my delete actually returns the actual book that it just deleted, the first delete would do that, but the second delete, the book content is gone, so it can't return that anymore. And my second request would actually be different than my first request, making it not idempotent. That's why I prefer to leave them out and make them idempotent by doing exactly the same thing. But relatively easy to do, although in most cases you do have to return a specific HTTP response message. So, hypermedia. Hypermedia is defined by Roy Thomas Fielding as the presence of application control information embedded within your resource or as part of that resource. And why would we want to do so? Well, let's actually go back to our browser for a moment and let's ask for this book's collection. We've got XML here, a bunch of XML. What can I do with this? Well, I can read it, but because I've got this, but what else? If I wanted to get just this specific book, book 4, Jurassic Park, how could I do that? If I've got that specific book, what can I do with it? I just said the convention is that I can do this and get that specific book, but that's just a convention. Nothing is saying that that should be the case. It might very well that I do something with ID/4. That would also be a valid URL. Except in this case it isn't, but I've got no way of knowing that. Well, hypermedia starts embedding information into our service, basically saying, okay, this is what you do. With a simple REST service like this, I've got to know my URL structure. I've got to know what I can do. I know I can get this because I just did, but can I change this? Can I put to this? Can I edit this? I don't know. I could try, and if I succeeded, apparently I can. If not, if I failed, well, apparently I can't. But it's kind of like I can only figure out what I can do by trying. Well, hypermedia makes that much richer. With hypermedia, you control or embed all that kind of information into your actual service. So with hypermedia, we're right at level 3, right at the top of hypermedia controls, where they get as nice and rich as they can be. So Microsoft came up with a protocol for hypermedia called OData. OData is actually, well, semi-standardized. Microsoft is pushing it as a standard. It's not, as far as I know at least, it's not really recognized as a standard yet, but there are quite a few companies working with it. But more importantly, it's based on something which is a standard. It's based on AtomPub, which is a W3C standard, which has been around for a long time, quite often used with blogging platforms to show updates on blogs, etc. But it turns out that AtomPub is very general purpose. You can do a lot of things with it. And OData basically builds on top of that. And one of the things it builds on top is metadata. With simple REST services, when we stick to level 2, there is no metadata, so you basically as a client developer have to know what you can do. You've got to know what types can be returned, what properties are there, or attributes I should say, stuff like that. As soon as you start getting metadata, you can do things like add service reference and generate code based on that. When it comes to OData, WCF Data Services is an implementation of that, where you can actually take an entity framework data set and publish it through WCF Data Services, and you'll get a big OData feed with the resources from your database or whatever you choose to expose as part of that entity framework model. Pretty easy to work with. But in our case, we're actually going to do it with the Web API. Here's an example. Let's actually open this link for a moment. Here's an example of an OData service from Nerd Dinner, a sample application Scott Henselman did, where he actually serves up the data. And let's actually remove that for a moment. Here you see the service. And you actually see something which is special to hypermedia service. Basically, you have to know the root URL, so OData/service, and it will tell you more about what's going on. So apparently this service has two collections, RSVPs and dinners. So we could go and say, well, we want to know about dinners. What actually says here, the href, relative URL, is dinners. So let's put dinners on this. And we get this long view. Let's actually switch to Chrome for a moment because it makes it somewhat easier to read. We get this big feed, big XML feed, basically saying, okay, we've got a title here, we've got ID, and we've got entries. Here's one entry, here another entry starts. And an entry has things like an ID. In this case, the ID looks like a URL. It doesn't need to. It's just some identifier. And stuff like when it's updated by who. But interesting stuff are these kind of things. We've got link elements of a relation type. So basically edit. I can edit this diner if I go to this relative URL. And I can get the RSVPs for this dinner if I go to this specific URL. So let's actually go to the dinner first. So it basically told us we could go there, and now we just have data for this dinner, and we could go to the RSVPs. So let's just copy that. And we see a list of people attending. We see names. I guess these are pretty fake names from the look of it. But stuff like that. We can get specific ones from there. We can get to the dinner this belongs to. But basically our data contains these link elements which basically describe how we can navigate through the application. Now I could find that by just starting with the root. Just go to OData.svc in this case, and it basically just shows me, oh, you've got dinners and RSVPs. You can go to /dinners to get the dinners. Once you've got dinners, you can go to a specific one, or you can go to the RSVPs for that specific dinner, etc. It's a self-describing document with knowledge of the standards and knowledge of the root URL. You can basically start traversing it and see all the data and see what you can edit. In this case, the relation type edit tells me that it's editable. I can change this. So let's go back. Dinners $metadata. This metadata actually describes what it looks like. So we've got an entity type called dinner, and it has a number of properties here. So basically, properties, dinner ID, which is an integer, title, which is a string, event date, which is a date, time, etc. It has a navigation property, so you can navigate from a dinner to something else, and basically tells us what kind of relationship it is, which is what set up our relationship from a dinner to its associated RSVPs. So a very rich model, a very nice capability to have. So in this case, we were just going through it in the browser, but there are generic tools like Power Pivot for Excel, but there are other analysis tools which you can just basically point to an OData service, and it will go and grab all the data and import it and can start doing with it. In the case of Power Pivot, it will embed them in Excel, and you can play around with data in Excel, which is very nice. So when it comes to ASP.web API and OData supports, there are two levels. Basically with this API controller I just created, we get the first level of support, basic querying support. You can add standard parameters to your query like $filter, $skip, $take, etc. and start querying for specific parts of your data. There are a couple of prerequisites to do so. First of all, I got to go to my service and I got to make sure that this doesn't return an IEnumerable but an iQueryable. And because my books collection is just an in-memory list, to see, does it resolve now? No, why doesn't this resolve? Because I've got a typo somewhere, but not seeing it. Is it sQueryable? Yeah, that was. So now it's an iQueryable. And I need to make one more change. In my web API config, by default, there is this comment. Basically, if you want to enable querying, you got to enable it on purpose. You got to uncomment this line, config.enable query support. This will basically enable it. Now there are some caveats to that. There are potential denial of service attacks possible with this. So make sure to visit this link and see what the potential pitfalls are and how you want to protect against them. You can add a queryable attribute to this and specify stuff like you can only do specific action like only order, top and skip, something like that, and not use filter, stuff like that. But let's copy this and let's actually go back to my books. So I've got the collection of books. Now in here I could say question mark $filter is, let's say ID equals 4 to get a specific book. Or I could say, let's say title is a specific title. And there we've got a specific title. Or I could go in and say, let's go back to the complete list. So we've got 5 books. $take is 2. And $take top. And it will just take the first 2. And I can tell it to skip. With $skip. So basically we can do server-side paging using these URL constructs. So this is really easy to implement. All I had to do is make sure that this returns iQueryable and that query support was added to the in the web API config. And you're good to go. Currently that just gives you filter, order by, skip and take, and the almost released next version of web API, it will also include expand and select, so you can actually do projections in there, but right now that's not supported. Here you see the queryable attribute basically saying, okay, if we didn't specify page size, take a default page size of 10. So we always work with the page size. It's kind of useful to add that in case of long lists. So the next thing we can do, if we say, okay, that's nice, query support is nice, but that still returns that original simple not hypermedia style resource, but we want hypermedia resources, we can do it in a different way. We can actually say, well, we're not going to use the API controller, but instead we're going to use an entity set controller, which is smarter, which actually understands how we can embed metadata. So I've got another example of that, this hypermedia books controller. Basically, I'm deriving from the entity set controller, saying, okay, I've got an entity set controller of books, which has a key property of type int. In this case, the ID is of type integer. The get is pretty much the same thing. Basically, just return an iQueryable. But instead of a get with an ID, now we override another one, the get entity by key, basically looking for a specific key, returning that book. And we don't have to worry about the fact that non-existing books returned as null will show up as a null resource. All of that will be taken care of. That will turn into a 404 not found for us, etc. And we can do the same with put, post, delete, etc. There are convenience methods. You can get to the low-level methods. You can get to the richer methods. All the stuff like model binding, etc. works. Of course, we need to define a route for this. So let's go to the config for a moment. Uncomment these few lines. Basically, what we're doing is we're creating an, oops, try that again. I'll get there. Basically, we're creating an OData convention model builder. So it creates an OData model based on conventions. In this case, there are very few conventions. It's really simple, but it will try to do the right thing based on naming, etc. You can also create a more generic one where you get full control. You can specify links and everything you would want to. In this case, I'm adding an entity set of type books called hypermedia books. So this hypermedia books basically maps to that hypermedia books controller which I created. I create an EDM model and basically create an OData route using the prefix OData for that specific model. So if we compile this and go back to the browser, and instead of going to API, go to OData, we should see the root. And just like we saw with Nerd Dinner, there were a couple of collections. In this case, there is only a single collection. And it says the href for that collection is hypermedia books. So we can go to hypermedia books and see what we get back. So in here we see we still get the data back as JSON, but at the top it actually adds something. Okay, there is OData metadata at this specific URL for these books. So let's actually go there and see what we get back. So you see the same kind of XML we got from Nerd Dinner back, only this is much, much simpler because there is a real simple module. But we see there is an entity type book. It's got a key of name ID, which is of type integer. It's got a title, author, image name, etc. There isn't much more to it in this case because my model is real simple. But I could start expanding on it and clients would just be able to know whatever I've added by looking at this. And even in Visual Studio, I could actually set a service reference to this and the tooling would recognize the fact that this is an OData feed and there is a book type there and it would generate a proxy and a book type for me, etc. So that's very nice. So let's go back to Fiddler for a moment. Let's get rid of all those requests and just do this one. We see when we look at the request, we get something of JSON data back, but we can actually start playing around with this. and say, well, let's accept something different. Application / atom, because OData derives from the atom standard, plus XML. So I want atom style XML back. And if I look at the response, you see we get this big XML feed, basically saying, okay, just like we saw before, we get those edit URLs, we get, it's kind of hidden away, we get this self URL there, over here, we get our actual content, so all of the data is there. So apparently, we can edit this if we go to this URL, basically hypermedia books 1. So let's do that. Execute that. We get a smaller response. Basically, this describes a single book. There are no links to other resources in this case, because there are no other resources. If there were, I defined them, they would show up. And the fact that there is an edit relation means that I can start adding this, stuff like that. So I can create much smarter clients. It's a very nice capability. It's harder to work with. It's much harder to get a proper hypermedia document with the proper links, etc., than just a simple REST services. But in this case, you completely describe how everything works inside, so generic clients can start working with it. And clients can adapt to things like the client can see that there is no edit link, so apparently it can't start editing. So things like a save button should be disabled. No editing allowed. And if the edit link is there, then the save button will be enabled. Stuff like that. So very nice capability, although, like I said in the intro, with hypermedia, it's hard. So I don't typically go there unless I've got a need. If I do public-facing services and I want generic clients to be able to work with it, and I want to be able to change things dynamically where they can just look at the metadata and see what's going on, fine, then I'll go here and I will use hypermedia and I'll use this support. But if I control both the client and the server, and I don't really care about the fact that my client has logic inside of it which knows about the UI scheme, which knows about what it can edit and what it can't edit, etc., then I typically don't go here. I just stay at the level 2 with using HTTP verbs, using HTTP status codes, content negotiation, although even that's probably not that needed if you control the client, because at least in my experience, quite often you'll just use JSON then. So here's an image of that OData metadata support we just saw. Here's another image of that same controller which we just looked at. And finally the routing piece we had to enable for it to actually pick up on the fact that OData was a valid URL. So if you want to get more into REST, there is one book I highly recommend. It's called REST in Practice. It's not about Web API, it's purely about REST. There are examples in Java and .NET in there, but this was written some time ago, so there's nothing about Web API there. But it's very insightful on how to create REST services, how to do the proper thing, things to avoid, things to be careful with, etc. It's by far the best REST book I've come across, so even though it's not about Web API, it's still highly recommended, and I would strongly advise you to read this before you start creating production REST services. So conclusion, Web API is pretty easy to work with. It makes creating REST services relatively easy. Of course, the concept of REST, it's an architecture, is not always as easy, but the technical parts of REST are real easy. I'm also using, say, Node.js and the RESTify framework there. And if I compare that to Web API, then Web API is a lot easier. There is less you need to do to get a proper REST service. So it's highly recommended as a service there. And think about hypermedia. Don't go there just because it exists, because it does add a lot of complexity. Think about whether you need it. If you need it for public-facing services, things like that, then by all means go there. It's highly recommended then. But if you don't need it, you control both the server and the client, then I would just consider it, but probably shy away from it and keep things a little simpler. But each case is different, so make sure you think about it and not just dismiss it out of hand. So that brings us to the question part. This is the last slide for my presentation. I see in the Q&A manager there are a few questions. Before I start with the questions, the presentations and all the source code I've just demoed will be available on my blog. The URL is below it. So probably not do it today, probably in 24 hours or so, but it will be there soon enough. And you will be able to download everything and play with it. And with that, I'm going to go to the Q&A manager. That was the wrong window. So how many parameters can be passed in? Basically, like it says, you can use anything you want, as long as you can use something which is valid in your scheme. You can go at it. In this case, using commas works perfectly fine. You can use slashes, dashes, or a regular expression if you want to. Anything really goes there. Let's see. Sub-resources. Yeah, basically you do something like this. Like in this example here, we've got book/ID, which returns the specific books, and then you'd create another route which says book/ID/author/author ID, and handle that. So you probably create different routes and just point to a specific controller to do that, because in that controller you would need to get both the book ID and the author ID and work with both of them. Oh, I guess, oops. No. So what strategies do you use for dependency injection in your API controller, e.g. the books repository? The strategy is actually pretty simple. Web API supports this by default, so it's just a matter of wiring up your favorite dependency injection framework. If you use something like the Inject, they've got standard classes for there. But the interface is actually pretty simple. It's just an interface with a couple of methods you need to implement and hook up on in the config object. By default, it only accepts parameterless constructors, but as soon as you hook this up, it will just work. Let's see, that was that one. When should the from body attribute be used? Well, model binding can look at different things. It just doesn't. It looks at things like the query string, what is it? The model binding. The root parameters, and the body. And there are cases where you want to make sure that it only uses things from your actual request body and not from somewhere else. So in that case, you would use the from body attribute. Typically, I don't use it a lot, but that's the main reason. So will security, authorization, authentication be covered in this webinar? Well, I guess not. Basically, security is quite a big subject by itself. Because REST services basically work on top of standard HTTP service, everything you can do for authentication with standard HTTP will work. So you can just enable basic authentication and look at the authentication header. You could do something with federated security there and add tokens, etc. Of course, authorization is something you handle in your own application. That's not Web API specific. The authentication basically says, okay, who are you? And the authorization is, what are you allowed to do? And the authentication is pretty standard, or a number of standard things. The authorization part is more up to you. Okay, now you know who the guy who called you is, or you trust that the claim he made about who he is true, and then you decide what he can do. Excellent presentation, thank you. How would you best secure your RESTful services and limit to certain users, such as phone tablets, that have installed your app? That's actually a pretty hard question to answer, because the way you formulate the question kind of assumes you've created an app and you only want your service to be callable from your app. However, your REST service is just an HTTP service and it expects incoming HTTP requests. And there's really no way you can be certain about where that HTTP request comes from. Yes, an HTTP request has a header, which is the user agent basically telling you the user who made this request, or the user agent, so typically the browser who made that request is specific. But that's just an HTTP header everyone can fake. If I go into Fiddler, let's go back to Fiddler for a second and go to the Composer, that HTTP header, user agents, right here. I can type in whatever I want and submit this. No problem here. So that doesn't really tell me anything. Where was my question window? What I typically do is I just use normal security practices and I don't worry so much about whether it came from a specific app. Because in the end what you're concerned with is whoever is calling me allowed to do that, and whether he does so from a specific app. I guess that's really beside the point. Now it's perfectly fine to say, okay, my app adds specific headers. Sorry, so you could recognize the request coming from there, but still, it's just an HTTP header, so anyone can just fake it, use Fiddler or use some other low-level HTTP request tool, adds headers. So if they monitor your traffic, there's no way you can be sure. Of course, using HTTPS is the first precaution there. If you do HTTPS requests, it's a lot harder to monitor things. At least you can't monitor it. While it's on the wire, you can only monitor it on the server or the client. But it's still no guarantee. Can we disable actions on entity set controllers, e.g. query only, no editing? It's really up to what you add. In the entity set controller I created, I only had two get methods, so it didn't support editing, it only supported querying. If I add a put method and a post method which allow people to change added resources, all of a sudden it starts supporting it, and then of course you have to write the code to support it. So you could add code saying from, well, you can only add it if you've got specific tokens. Maybe anonymous users are not allowed to add it, but system administrators are, etc. But your basic start is just supporting methods. And if you only support get, there is no editing whatsoever. There is only querying capabilities. Can I have multiple posts or gets? If so, how? I'm not quite sure I understand that, but methods can be overloaded, like we saw with the get. I had just a get without a parameter which returns a complete collection, and I had the second get which took an integer ID parameter which returned a specific instance. That's basically having two gets, so I guess that's yes, you can have multiple gets. You could do the same with posts. You can overload methods, although with posts it's not quite as likely. You typically do a post to the collection to add a new resource, and that your controller is already about a specific resource, so it's less likely you'll have another post in that same controller to add something. Because after all, if it's a different resource, it should really be a different controller. But in theory, you could overload methods, and routing will look at the incoming request and the parameters, and will see which should respond to the request, just like it happened with the get and the get with an ID. In model names are parameter names case independent. I'm not really sure. Let's do a quick test. I normally leave them lowercase. It's over here. Let's make this uppercase and see if it still works. Where's my browser? Yeah, it still works. I still get a specific book with ID 2. So I guess that things are case insensitive there. It doesn't really matter. The name does matter. If I change it from ID to book ID, etc., then it would matter. So I'm not seeing any more questions. Anything here? No. So unless people have more questions, I would like to thank everyone for attending. I hope it was a useful course. Make sure to grab my demos from my site tomorrow. Let me get, where's presentation? Let me put the URL up one more time. So msmvp.com/blog/the-problem-solver, or just Google my name, Maurice de Beyer. I'm not a hard guy to find on the internet. And feel free to contact me with any questions you have through my blog. And with that, as I see no questions come up in the Q&A manager, I'd like to call it a day. Thanks for attending.
Thanks everybody. That was definitely an excellent overview of the web API and how to deal with REST services. A quick note to people, I have a URL here. I'll quickly throw up that talks about, can we get it up? Using class certificates to secure ASP Web API. So I'm just going to quickly bring this up. There we go. There we go. Should come up in a second. Anyways, this here, that's a particular blog entry by Petra that explains how to use class certificates to authenticate this web API. Anyways, I am going to just, if you look down the bottom, you can see the URL itself there. I'm just going to try to find a way to give it to you guys as well. The text page, here we go. I'll leave this one here for the time being. If anybody want to grab it, this particular blog post can give you the step-by-step for the client search. Anyways, thank you for everybody that attended today. I hope you enjoyed it. Maurice will be back again with a handful of presentation in the coming months as well. And thanks to Maurice for taking the time out. I know it was very early morning for him today.
It's actually evening for me.
Evening for you. That's
yeah,
right, it's early morning for me. Yeah, oh, you can hear me now.
Yes, I can now.
Good. All right, thanks everybody. I'm going to stop recording.